Evan Reese here. Drape Surface is a custom feature that I wrote for Onshape that lets you take a target surface, an input like this, and project it kind of like a sticker onto any other nearby object, in this case, this body. So let me show you how that works. And then I'll get into why you might want to use it. So if I can grab the input and then I can grab this body, you'll see that suddenly we have this surface that is a pretty close approximation of that body. So there's a couple of reasons why you might want to do this. The two main ones are for mesh workflows when you're trying to approximate a mesh, and another would be to create a grid for downstream features. For me, that's usually my Attractor pattern custom feature if I'm trying to create some kind of subtle texture on a product. All right, so let's go and look at an example of like where this feature might come into play. So this is a model that's a 3D scan of an airplane port cowling. I became aware of it on the Onshape forums. This is from Dr. Kenneth Sebastia. I think he's Boston University. So he's been working on this aircraft, and the idea is to update it and using 3D scans and 3D printing to do stuff like that. But the challenge was to take this 3D scan data and then model on top of it so that you actually have something nice. So, workflows like this are going to be very labor intensive and not produce clean results. This is, the more cross sections you manually are placing in a loft or anything like that, the more it's going to be over constrained and fighting. So you want to have as little input as possible, but it also, in this case, you want it to be very accurate. So you have opposed constraints that are hard to find a balance with. So this was a thread that got my gears turning on working with mesh in the first place. And if you haven't seen my two previous videos where I use a 3D scan of a boot and create a part that fits to that perfectly using the new constrained surface feature, which actually didn't exist when this thread was made. And then I have another video where I cover a bunch of additional tools that I've made for working with meshes. So this Drape surface is kind of like the closeout of that exploration for me, and I'll probably turn my attention to other challenges. But anyway, so that's what that looks like. And I want to show you what you might have to do without Drape surface so that you understand where it's valuable. So what I'm doing here is I'm going to prepare this mesh. I'm using my own custom spline on mesh feature to create the curves that I need and split the face. I'm just trying to clean up the model. So I used my custom feature called keep face, which is just like an inverted delete face. And that just made it easier for me to because I'm splitting it and there's all this like leftover stuff. There might be little bits and little faces everywhere. So I'm just choosing what I want to keep to clean it up. And my idea here is that I'm going to use a constrained surface per quadrant. So this whole section is going to be one constrained surface. And then I wanted, there's no way to really control like the boundary conditions of that. So there was going to be a seam where each of them met. So I split it, I put a gap between them, and that's how I went about it. And each one of these, it overbuilds a bit like that. So then I had to do some work to get those all split and cleaned up. So now I'm left with this, and I bridged across them. And it's workable, but I don't love the result, and I don't love the feature tree. So constrained surface, as of right now, cannot handle any closed surface. So like, a cylinder, the side of a cylinder is a closed surface. It can't do that. It can only do like open four-sided shapes. So if I wanted this as a single constrained surface, can't do that. So let me show you using my custom feature. Here's the result that we got. It's one single surface, and it fits to the part quite well, and the structure of that surface is not too bad. Now this is going to be jaggedy because it's a loft, but if I pull that down and let's increase the count here so you can see the structure of this surface. 64, not too bad. And I could probably work this little wobble out if I cared, but I think this would be totally good enough to work from. So let me show you my workflow for getting this with Drape surface. I just created these two curves using my spline on mesh and projected curve custom features, and then used my Freeform Spline feature to create connections on the loft. I like this feature for doing loft connections. Let me just show you briefly. So it's a great way to connect between two different curves for surfacing workflows. I can just grab the edge, and then I have a nice point I can drag around on that edge, which I love. And then if I add a vertex and choose the other edge, it will snap to the closest point from where it was. So it's going to snap to a fairly reasonable location. And then if I needed to, I can go insert mode, pick this point in the middle, go back to create mode, and now I can add a little bit of curvature to this. So there's a lot of things that I used to do with Freeform Spline that now I'm going to continue to experiment using the new-ish routing curve feature that's native. But there's still cases where I still reach for this feature, and I'll probably make some updates to it based on certain things that I've run into. Anyway, so from that, we get a loft. And with Drape surface, really the input surface, you can think of it more as a grid. So it's going to just transpose, or it's going to project whatever this grid is onto the other face. So this is the structure of my grid. And if instead this grid came way over here and did something loopy like that, that would be bad. So just you want it to look tidy because that's what you're going to get when it projects. And that's it. So inside of Drape surface, I'm using that loft as my input. I'm using the mesh as the target. And then normal to tool and some of these things. I'll go through step by step through the feature in a second once you understand kind of whether or not this is even the feature you're interested in. So that's one workflow, and I think the result is pretty good, speaks for itself. I, in a previous video, talked about the Stanford bunny. This is a classic mesh model that's used for all kind of benchmarking, and I tried to replicate the ear of that feature using constrained surface, and it worked okay. It was good. I drew a seam using my spline on mesh feature, split this ear, and then used two constrained surfaces side by side, and then a lofted or boundary surface or something between them to smooth out that seam. So let's take a look at a workflow that we can do using Drape surface. So on this one, I had, well, I'll just walk you through it. All right, so here's what I have to begin with: the entire mesh. And I used my Freeform Spline feature again to create an axis that just, I'm eyeballing it, is the middle of the ear. And then I used a mate connector on the end of that axis as my split for my mesh copy and split. So what that does is it makes a copy of just the area I want to work with without editing the original mesh, which is nice. And then I used my 3D points custom feature. This stack actually is a lot of custom features. It's just amazing that Onshape, they had the foresight to build that in, because no out-of-the-box software is going to meet everybody's unique needs. But FeatureScript really makes it possible to customize Onshape to exactly how you want to work. So yeah, if you think that a custom feature might speed up your workflow or something that you do for your business, let me know. Let's get in touch and talk about it. All right, so then I used my 3D points custom feature, again using that curve that I placed, and I used that to create these planes on there. I like this feature plus a curve as a good way to make a bunch of planes that are very interactive with each other, and you can make a stack of them all in one go. So that's what I did. I sketched on each plane a section that is close-ish, to the ear. I'm not worried too much about it being all that close, because that's what Drape surface is for. This one is set in just a little bit, and I'll explain why in a second. So yeah, I lofted from here to here, and that got me pretty close. It's okay that this is poking through. It can handle that. So now that's going to be my tool surface, and I can use Drape surface now to kind of like suck that tool surface down onto the ear. And it doesn't matter that it's a closed surface. Not bad at all. This one I'm using B-spline surface. If I needed to prioritize fitting the mesh really exactly instead, I would use loft probably. And yeah, so you can see that's a really close fit, but the surface quality is going to be worse. But that, it can work. I'm just going to exit out without changing anything. And then to finish this off, I just Shift P to hide all the construction stuff. To finish it off, I'm just going to use the fill feature with that one edge set to tangency. And then I'm going to grab a few of the mesh points as guides. So this will help me get close. And I could fuss with this more and get it closer if I really wanted to. Right. So yeah, that's how I would use it on this section. And it's a nice, clean result and a fairly short feature tree. So I was pretty happy with that. And then a last example I want to show is for a different use case. This is for the attractor pattern use case. On a model like this, I have all of this really tidy surfacing, but a lot of times that means that you're working in patches, and I want a pattern that crosses over multiple surfaces, which is pretty hard to do otherwise. So what I need for attractor pattern is a base surface, which is basically just a grid in 3D space. So I created a loft, basically from here through some guide curves over to here, or through some section curves, and then used these edges as guides. So anyway, I got a loft that was very, very close already. It's already pretty close. And then did some trimming and used Drape surface to pull that loft right to the part. And you can see the way that this is like kind of overlapping is because the render meshes for both of those parts are like touching each other. So anyway, that artifact can be kind of a handy clue as to whether the parts are really close. Trim that back, added a sphere as the input for the attractor pattern, and then used that feature to get a result like this, which I was really happy with. How subtle that is, how well the grid flows, how even it looks. So yeah, I think little subtle details like that can really elevate a product. Also, if you're interested in just how I surfaced this pan, I think there's some subtle things going on here that maybe you would learn something from. So if you're into surfacing and you want to see a walkthrough of how I modeled this, let me know in the comments and I will hit you up. Okay, so that's how the feature, like that's the kind of outputs that you can get. Let me go through step by step so you can see all of the buttons that you might want to know about. So we'll go here and do that. So top to bottom, the tool, this is your surface. And this surface, I again recommend that you just think of it as a grid. So whatever grid your input surface has, that's the grid that we're going to project down, which means that this needs to be an untrimmed surface, preferably, or a simple surface. It's if you want to see what the grid looks like of your surface, you can, as I've been doing, click that, Shift C, and that's going to bring up the curvature combs, and you can drag this all the way down. 10 by 10 is probably a more reasonable grid. I guess we don't have U curves because there's no curvature in that direction. You can also use the face curves custom feature that I wrote, and that's a good way to get a grid. And I find myself using this. It can output a composite part. So this is those curves, and you can edit the appearance of that to something that will stand out in your model, and then use that as a diagnostic later so that you can see the results. I'll show you. Let me show you. So we'll get rid of that. I'll do that again later for you. So let's go through draping this surface onto that body. So here's my tool. My target can either be an individual face or set of faces, or it can be a whole part. I can grab that from here, or if you mouse over near the silhouette, you can see how the whole silhouette's orange right now. So I could click that, and it's the same as clicking here. Can be a little tricky to do, but it is nice to know about. Okay, so moving on down here, I'm going to turn on these two previews so you can see what's happening. I want you to understand how the feature is working in the code so that you can kind of conceptualize and troubleshoot a little bit better. So I am creating a grid of points on the tool surface, and then each of those points is getting projected down onto the target, and then I'm creating something through that. So in this case, with loft mode, I'm creating fit splines through those points and then lofting through them. And I have found that that's accurate enough, actually, for what I'm doing. I had done a different version in the past where I was using project curve, so that it was very, very accurate. And I found that that actually slowed it down and was causing me some challenges and really wasn't worth it. But that does mean that you would struggle to have any abrupt changes to capture something like that. Like if I were to try to wrap it around this corner, to capture the detail of that little corner, I would need a very tight point count. So if you are using the feature and you find yourself running into that kind of thing over and over again, let me know. But as of right now, I'm trying to keep it simple. So anyway, yeah, if something like that would be useful to you, let me know. Okay, so the projection type. Each of these little cyan lines is showing you the points coming from here, projecting down to there. And there's a few types. So normal to tool means that these lines are going to come straight out from the normal from the tool face. You can also do normal to target, which is kind of the same as like from this point, what's the closest point on the other part. And this is more like the result you would get if you actually used the project curve feature, like that. So if I had curve to face, and I say normal to target, that's what it's going to be like. So what the issue with that in some cases is that you end up with this very warped grid, and remembering that kind of the grid is the goal. So I find that often normal to tool is going to be a cleaner result, more control. It also can be a little bit more computational. So if you can get away with using normal to target, maybe do that. And then direction, I think, is fairly clear, but I can choose a direction and all the points will just project exactly in that direction. In this case, it only gets points, not on both sides. So when I'm projecting a point and I miss, I'll highlight it red for you. So you can diagnose. So in this case, that lets me know I just need to flip the direction. And all of these are projecting straight down. So that's how that's working. I'm going to switch back to normal to tool and move on. So these are both the previews, and I've got this message here, and the feature turns red if these are left on, because they do take computation to do, and they don't change the output of the feature. So you just want to turn them off when you're done using them, and it'll make the feature itself perform faster. In some cases, meaningfully faster. So let's actually take a look. 56 milliseconds is very, very fast. That's fine. And then I can turn this on, both of those. And now we've gone up, like 4 times or something. So it's meaningful. You can also change the point count here. This is going to give us more section lines and more points per curve. So the accuracy of our approximation is going way up, but the performance really suffers too. So you want to strike a good, well, actually that's not too bad either, about 1/3 of a second. But you want to strike a balance. You don't want to make it overly precise because it's just too computationally expensive. You want to kind of find that Goldilocks zone. Okay, so that is the point count. Drop it back to 10 so that it's really snappy. Here's our grid. So this is all about how we're going to project the points, project our grid onto the target. And this section is all about how we're going to make a surface on that grid. So we have 4 methods here. We have loft, B-spline, constrained surface, and fill. So loft is creating these section curves and lofting through them. B-spline is just using the points themselves and creating a B-spline surface, using those as the control points. Worth noting here that the surface itself doesn't touch those points. It's the same as if you did a Bezier curve. Let me just sketch this here. So see how the curve itself is not touching the control polygon. B-spline surface works in the same way. So that's worth knowing. But there are some advantages too. So if I turn on the curvature combs with Shift-C, turn these down to be something a little bit more reasonable, that's going to be a little bit jagged. Let me show you what loft looks like. Loft is even more kind of jagged because the result of a loft is only ever a degree 3 surface. But here we have the option to increase the degree. And as we do, you can see these curves smooth out. Let me change it to something even fewer. We don't need that many. So you can see that's starting to get really smooth. But the approximation is even further. You can see these points are way up here. So that's where our actual target is. So to balance that back out, you might crank these way up And it gets to be pretty heavy. I'm going to turn off this point grid. But now it's going to be a lot closer. So just depending on the level of accuracy you need for your approximation, B-spline can be a really good way to go if you need it to be smoother instead. Another great option that we have to work with here, especially for something like this, where it's just like a nice rectangular surface, nothing closed, is constrained surface. So constrained surface right now is designed to work with meshes and grab all the points from that mesh and try to fit a surface through that with some approximation. You know, you can like loosen it up. But there's not a great way to do that onto analytical geometry. So what I'm doing here is just, blasting a bunch of points onto anything and then making a constrained surface through that. So really nice workflow if you need to approximate something. I can change the tolerance to loosen this up. I can set it to prioritize smoothness. And we can get a pretty good result here. And then the last one is fill. I'm going to drop these down again. I think fill is probably the one I will use the least. What it's doing is it's creating a boundary. These curves, all the edges. It's making a fill there, and then it's using this grid of points as the guides. So it's the same as if I used the fill feature, grabbed these 4 edges as my fill, and then for my guides grabbed up all of those points. It's probably just going to perform like not great, although that's not too bad timing wise, and I still have the grid on, so it might work. It might work for what you're up to. That's actually pretty quick. So you have options to play with, and I can't tell you exactly which one's going to be the best because it's kind of case by case, but they're all there for you to use. And then last, if you want to keep the input tool, you can do that here. Okay, so that's a pretty comprehensive tour of Drape Surface, what you might use it for, and how to totally use it. So if you do use it, let me know in the comments. If there's areas where it doesn't quite do what you need it to do, let me know. I would love to hear about that. Otherwise, thank you for watching.